Okay, just want to make sure you can complete the questions now on homework number 12. And I wanted to flip it over. We just got through talking about an example, but now let's look at our first item on the homework sheet. We've got bubbles of carbon dioxide are released when nitric acid is added to a sodium carbonate solution. Water and sodium nitrate also form. Now, water is a liquid and sodium nitrate is aqueous. When they're aqueous is what we are going to be using to decide when we're going to be going from the regular to complete ionic or to net ionic. I'll explain in this example, okay? So here is the equation. We have nitric acid and sodium carbonate. That's nitric acid and sodium carbonate are reacting. They make CO2, water, and sodium nitrate. Now these two are aqueous, but the products are gaseous CO2, liquid water, and sodium nitrate aqueous. Okay, that's like a normal equation like we've done before, writing out from words to formulas. Yeah, I know you love it. It's a challenge, but they're in words, from words to formulas. So we got the formulas. Make sure you write those down for your first assignment 2A. And then when you have it as aqueous, you're going to break it down into its ions. Break it down into its ions, including the subscript, okay? And then you're going to be going in here and doing, these is gases, this is liquid. They don't break up, but this does. Now, the thing about this is that we need to balance it. I forgot and didn't notice that it's not balanced. So we want to put a 2 here and a 2 here, and then this one, and then a 2 here. And I totally forgot about that when I go through my example here. So we're going to need to have 2 ions here, 2 ions here, and then 2 ions here and here, like that. So now when we do this here, this is considered the complete ionic equation because this aqueous solution is broken up into its ions. This aqueous solution is broken up into its ions. And that is the essence of going to be becoming the complete ionic equation. So what we're doing is, this is the complete ionic, this is the complete equation, this is the complete ionic equation. So now we're going to then do the total ionic or the net ionic. So we're going to then take it is where we are going to cross out both sides, okay? So we're going to take the equation I just wrote out with the balanced ions, okay? We're going to cross out the ones that are identical. So you see H positive on this side, but you don't on this side, so you can't cross that out. You have 2 nitrates on this side, and you see it over here on this side. So when you see it on the right and when you see it on the left, you can cross that out, okay? Then you also go back and look at the sodium on the left, the sodium on the right. Notice that they're both charged with the exact same ion charge. These are aqueous ions, okay? And so what happens is that these two also cancel out, okay? So originally, they were the complete ionic, and now with them canceled out, we only have the hydrogen ion, the carbonate ion, making CO2 and water, okay? Again, the gas and liquid do not break up. And then when you take everything away, this is the complete ionic. And if I flip the paper here, now the final equation is the net ionic, okay? And what happened is that sodium and nitrate are both ions, are on both sides, and so they cancel out. These are what are called the spectator ions, okay? So we have the net ionic as hydrogen ion plus carbonate ion makes CO2 gas and water liquid. That is your answer for the net ionic. In the questions, you're trying to write the ionic and the net ionic for each one, for 2A, for 2B, for 2C, and 2D. And just note that when you see bubbles, it's a gas. Hydrochloric acid is considered aqueous. ammonium sulfate's aqueous and ammonium chloride's aqueous. So when you get this all written out, these three are going to break up into their ions, and some things are going to cancel out for your net ionic. Down here for the next one, you got potassium phosphate, that's aqueous. You have liquid water, you have aqueous phosphoric acid, and you have aqueous potassium hydroxide. Again, these three will break up, but you're only going to have water that doesn't. And so the ions that are involved with forming water are what's going to stick around. It's going to be very similar to the answer up above here. You'll see pretty much that same answer for your net ionic for letter C. And then down here we have solids, calcium sulfate, and aqueous magnesium nitrate form when solutions of magnesium sulfate and calcium nitrate are mixed. This is very much like your double replacement precipitation reactions we did on Friday. And so this format for D will be very much like what you're doing for the net ionic for your lab equations. Okay, so you're going to have aqueous, these two aqueous solutions, just like we're in those droppers, and they're going to break into their ions to form a solid precipitate and an aqueous magnesium nitrate. And so this guy stays together, but this one can break apart, and the two reactants can break apart. And then you're only going to be having the calcium and the sulfate ions left over, producing solid calcium sulfate. And tomorrow you're going to be having Miss Christine nearby, and she's going to help you clear any of these up, okay, that you're having trouble with. Now, let's move it on just to go over the basics of this. I kind of wrote it out on paper, okay? So you're going from a regular chemical equation to a complete ionic equation. You need to separate aqueous ionic compounds or acids into their ions. That's what you're doing. That's the additional step. But I want to emphasize that gases and liquids like water, and then any precipitates or solids, they do not separate. Only aqueous ionic, and then actually only strong acids go into their ions. Okay? You're going to cancel out like ions or spectator ions on both sides. And all this is happening on homework number 12 and number 20, and on your single and double replacement reactions on the lab. So I wanted to point that out to you right now and finish up the video with your lab here. Remember how we did this single replacement reactions? We also did it with double replacement. We should have had reactions on these 7. But what I wanted to do was walk you through a equation with magnesium and zinc and show you how to do the complete and net ionic equation that you're doing for your lab question, which is right here. You can select any 2 reactions above and write it their net ionic. You don't even have to do the complete ionic. You can, because you need to do that as a little homework before you get the net ionic. Okay, so let's load this example. This is the equation between magnesium and zinc nitrate. Magnesium is a solid. You added drops of zinc nitrate, and that's aqueous. And then the ions, the magnesium and zinc are going to switch. So you have magnesium nitrate and zinc as products. Now what you're going to do is you're going to have them, the aqueous compounds are going to break up into their ions. So here we are. I'm going to show you this one. And we're going to have magnesium and zinc nitrate breaking into its ions as reactants, okay? And then we have magnesium ion, which is different than the solid neutral. This is neutral. This is the ion that's dissolved in water now, with nitrate, okay? And then we have zinc solid being formed. That's the fuzzy stuff that was growing on the magnesium, okay? So this is considered your complete ionic equation. But when we're going to then break it into its net ionic, okay, we have the complete ionic here. But the difference is that magnesium is a solid. Over here it's an ion. You can't cancel those out. They have to be identically the same thing. This has no charge, but this has a +2. The same with this zinc ion that you started with turns into the solid zinc, and you can't cancel that out. But you can cancel the nitrate here and the nitrate here. They can be canceled out. You can cancel this out and cancel this out. And when you cancel that out, you have now the net ionic. Magnesium neutral, zinc ions react to make magnesium ion and zinc neutral. These two are not identical. these two are not identical, okay? When you go from the complete ionic to the net ionic, they have to be identically the same charge, the same formula, and they're going to be these aqueous ions, okay? So it just gives you an example. On your lab, you're trying to do at least 5 reactions here, and then take 2 of them to do the net ionic. The same is with your double replacement. I didn't bring a paper with me at the moment, but you're going to do the same thing. You're going to have 10 reactions. You're going to have 10 of the reactions for double replacement, and then you're going to have 2 additional for net ionic, okay? Again, if there's any questions or anything, feel free to get a hold of me on email on this assignment or on the homework.